what I want to talk about is the seasons and how they come about. How is it that we get the seasons on Earth? So, we have spring, summer, we have the fall, and we have the winter. So, and every year we go through each of these and they just continue. We have spring and then summer and then fall and then winter and the next spring, etc. And these are a yearly occurrence. And some places on Earth they are more extreme. Some places they are less extreme, but there is always some change in the season no matter where you live on Earth. So, what we know is the Earth is spinning. This is what we know. And it's spinning in this direction, and it spins once every day. So, this is one thing. The Earth itself is spinning in space, and it just goes on. And each day is one spin. That's how we count a day. So, also, the Earth is going around the sun. So let's bring out a sun. Here, turns on the sun. Okay, so the Earth itself is spinning, and it is also going around the sun. It spins once each day, and it goes around the sun each year, right? Now, there are 365 spins that take place in one circle around the sun. 365 spins, one orbit around the sun. And that's where we get the days and years, and why we have 365 days. Now, also, in relation to the sun, to the Earth, this distance, well, of course, the sun is much larger. It's much larger than the Earth. But this just shows a source of heat and light in relationship to the Earth. But the distance is 93 million miles. And we have heard, and we know, that light travels very fast. Super fast. But it still is so far away that the light leaving the sun takes 8 minutes, even at its super fast speed, to get to the Earth. 8 minutes. So if there's something happening on the sun, it goes blip. We don't see it for 8 minutes. That's how long it takes. So anyway, we've got 365 spins. We've got one orbit around the sun, and that's 1 year. Now, the thing about the sun, the Earth, is it's spinning. And when you've probably seen this, where you watch the sun go down, right? Or you've seen the moon come up. And you think, boy, it's kind of slow, you know, it seems to just barely move. But you look a little later and, oh, it's moved. And you come back a little later, oh, it's moved a little bit further, right? And it seems awful slow. The fact of the matter is, the Earth is spinning at about 1,000 miles an hour. So you standing on Earth right now, even though you're just standing still, you're traveling 1,000 miles an hour right now. Very fast. So that spin, even though it's such a big world that 1,000 miles in an hour is, it takes a while. But it's a big Earth. So it's spinning, and because of that spin, it always has, you see this point here and here? It always stays the same. It doesn't rotate through space like this. It just always stays the same because it's spinning. And interestingly enough, and this is where we come to the reason for the seasons. The Earth, in relation to the sun, is not exactly lined up to where the middle of the Earth is directly across from the middle of the sun. It's actually tilted. And this is why whenever you look at a globe, how come they're at an angle? Well, because that angle is the true angle in relationship to the sun. So if you set this on a table, that angle is the relationship to the sun. And because the Earth is spinning, that angle always stays the same, no matter where it is in its orbit. At this point, it's here. At this point, it's like this. You see that? And at this point, it's here. It's always the same. Never changes. Never. Always the same. So, year by year by year, that angle stays the same. And that's what causes the seasons. And this is why. Here's the sun, and it's full of light and heat, a lot of radiation. Now, you see, when the sun is pointed right here, this is the most direct line from the sun to the Earth. And the most direct radiation creates the most heat. Now, when it's less direct, it's less heat. So up here at the North Pole, for example, this is the North Pole, the light is not so direct. And so it's a little cooler. And down here also, it's a little cooler. It's only the hottest right here. And then as you go here, it gets cooler and cooler and cooler, and cooler and cooler and cooler. But it's always the hottest here. So let's say here you are in Europe. Well, it's hottest in Europe, but down in the bottom of South America, it's the coolest. It's the hottest in America, but it's cooler in Australia, just because of that angle, and it's always the same. Right? So, as the world turns, we've got this part of the world, which is above that line. That part of the world, in this relationship to the sun, is hotter. And this part of the world is a bit cooler. And it isn't a tremendous amount of difference, but it's enough to make it summer here and winter down here. Now, as the world is turning and it's rotating around the sun, you get the Earth is on the other side of the sun. And remember, we still have the same tilt, just like we did here, right? It's the same. Same tilt. Now what happens? Look, the southern part of the world, below this line, is getting the more direct sunlight, the more direct radiation. And the northern part is getting a little bit less direct radiation. So it's going to be at this point in the orbit of around the sun, this part of the world is warmer than this part of the world. Okay? So you have times of the year where it's warmer and then cooler. So let's come back here. Here we have summer in England. All right? Here's summer in England. And you can see it's up here at night. It's way up here. But it's hot because it's more direct, right? It's getting more direct. Now, this same point in the winter, look at where is England now. It's pretty cold compared to South Africa, where it's hot. So here's England at night, in a day. During the winter time, it's cooler. So that is what is at the basis of all the seasons on Earth. So if you live in Australia, which is here, okay, down here, when the Earth is here, it's cooler in Australia. They have winter when in Italy, it's summer. Summer gets really hot because the sunlight is very direct on there and less direct on Australia, which is down here at the bottom. So we have what we call in the northern part in America is summer. Here's this. Now here, 3 months later, we have fall. All right, it's after summer, but we're not all the way to winter, but we're halfway, and that's what we call fall. And it's not as cold as it will get, but it's not as hot as it was, right? And that's fall. And then as it approaches this part of the orbit, 3 months later, it's now the middle of winter in the north, right? South has got their summer when the Earth is here. And then 3 months later, the Earth has come around here, and we have springtime. And it's warmer than it was in the winter for the north, but cooler than it will get in the summer. So now it's summer again in the north. And similarly, as I said, in the south you have winter here, and here it's springtime in the south, but up here it's fall. So we have springtime here, fall here. We have summer in the south, winter in the north, okay? And here we have, now this has become fall for the south and spring for the northern part up here, okay? And then we're back to this part of our orbit 3 months later, where you have summer in the north and winter in the south, okay? So, let's move our sun and earth away. Okay, so springtime is when we have the earth is midway, right? Midway. Summer, we have the most direct sunlight, right? Most direct sunlight. Then fall, again we have a midway. And then in the winter, we have the least direct sunlight. So that's what causes the seasons.